Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 8, Lesson 1, Adding Decimals. My friends, I've talked to you all year about how the strongest mathematicians are always looking for patterns, connections, and relationships. They work hard to understand the big ideas. And that's where their procedures and their understanding and what they do, their steps, comes from. I believe that if you understand place value and regrouping, I think you already know how to add and subtract decimals with regrouping. Now, I know what you're thinking. Miss Foster, you have not taught us this yet. Clearly you're wrong. But if we understand place value and regrouping, and decimals are part of place value, then don't you already know how to do that? I say yes. With this one last tiny piece of information, you gotta line up the decimals. Yes, you do. You gotta line up those decimals. You gotta get them in line. Let's see what I'm talking about. Come along. Now here we have 4/10 plus 2/10. You will notice that they have used our stacking algorithm, which is particularly useful when we're dealing with issues of place value, because we know how to regroup this. But do you see how when they did this, they lined up the decimals one above the other? This is because the decimals help us to keep our places of value organized. The 4/10 is in the 10ths place, and the 2/10 is also in the 10ths place. Having done this, I think you know how to add this. 0 plus 0 is nothing. Decimal point? Yep, because these are tenths, and the decimal will help us stay there. 4 plus 2 is 6. Here we have 5/10 plus 6/10. Do you see how they have lined up the decimals for you in a nice line? And I'm going to continue that right down into the answer because I use this algorithm, stacking, because it organizes all of the places into their place. So 5 plus 6 equals 11/10. But my friends, just like when we did it with whole numbers, can we put 2 digits in that place? I should think not. So instead, we're going to put the 1/10 here and take those other 10/10 and regroup them into the single ones place. Now, for some reason, regrouping across a decimal point can feel a little weird. But if you really understand place value, you know that the decimal point is just helping us to put everything in its place. The pieces and parts over here on the right side and the whole numbers on the left. 1 plus nothing is 1. 11/10 is equal to 1 and 1/10. And if we were doing that with fractions, you would totally agree with me about that. You would say, oh, well, if I take 10 of these tenths, I can make one whole thing. And that will leave me with just 1/10. So we can do all of this work with regrouping. Let's try it this way. Okay, I've got my tenths over here, 3 and 5/10, 2 and 9/10. 5 plus 9 is 14. Tenths, I'll leave the 4/10 there, and trade up those 10/10 into one single one. And 1 plus 3 plus 2 is 6. Now, wasn't it nice when they did it for you like that? Well, down here, they're asking you to copy and write in what they call vertical form. I think at school we call that stacking a lot. And all we're doing is asking you to use the decimal points to line everything up. You just gotta line up the decimals. You can see here that all of the decimals are in fact lined up. And that way I know that everything is in its right place. 3 plus 5/10 are 8/10. I've brought the decimal down right there. And then 2 plus 3 is 5 single ones. But there is a trickiness here. Right here it says 5 and 9/10 plus 8. Where to put the 8? Now, if we were adding 59 plus 8, then you would have automatically put the 8 in the single ones place. But when you were doing this, did you know that whole numbers, you can put the decimal point with them all the time? In fact, if you spent too much time with me in class, you know that I always write it there. It's always there. We just don't use it for whole numbers. If 8 is a whole number, it's 8 single ones, and that means it needs to be in the single ones place. But now, right here, this having an 8 with a decimal point and nothing over here, I don't know about you, makes me feel a little queasy, a little seasick. Oh! So I would like to confer upon you once again the power. You have a right as a mathematician to write as many zeros to the right of that decimal point as you need to make it make sense. Now, if I do it this way, now, does it feel a little less seasick to you? I mean, that 0 is very large, but 9/10 minus no tenths is 9. And 5 plus 8 is 13. And this vertical form, this stacking algorithm, it just helps us get that 10 right into the tens place. Over here, we're going to do some regrouping. 6/10 plus 8/10 is 14/10. I'll leave the 4/10 there and take those other 10/10 and trade them up for one single one. Now, of course, I'll bring down my decimal point. I'll keep everything lined up because these are tenths. I had 14/10, and I regrouped 10 of them into one single one. Then I have 1 plus 7 plus 4, which equals 12. And once again, this algorithm is just sorting everything for me so nicely. And the decimal point here is all lined up. But what if we had hundredths? Would it change? Well, here I have 4 and 5/10 plus 6 and 48 hundredths. But if I go back to my rule that I've got to line up the decimals, I'm just going to make sure they all occur in one straight line like that. When I place them there, I might once again feel just a little bit seasick because I'm not used to having this empty spot right here. So I'm just going to take my royalty given right as a mathematician to write a 0 in the hundredths place if I want to. They're there all the time. I mean, if I just love those placeholder zeros, I could put one here and here. They're there. I don't have to, but could if I wanted. And aren't there 0/10s here and 0/100ths? I can put them there. You can put them there if you want. You can even move over the plus sign. Now, I'll tell you the truth though. I don't need these ones in order not to feel seasick. And I don't need these ones in order not to feel seasick. And you know how mathematicians, they like to do the least amount of writing possible. So I'm just going to leave this one here and go ahead and do my addition. No hundredths plus 8 hundredths will equal 8 hundredths. 5/10 plus 4/10 will equal 9/10. And 4 plus 6 is 10. I can use that same algorithm. I just got to line up the decimals. Here they've asked me to add $10.25 plus $6.35. Notice, please, that I have gone right ahead and lined up my decimals in advance. I will just highlight them in a tiny bit of green. That just puts everything in its place. And now, I might want to watch out for some regrouping. So just like when I started in the single ones place for whole numbers, I'm always going to start in the smallest place of value. And if I wanted to put some more zeros here, I sure could. I could start in the thousandths place. 0 minus or plus 0 is 0. 5 plus 5 is 10. 10 hundredths make 1/10. So I'm going to go ahead and put a 0 in the hundredths place and write myself another 10 in the tenths place. I'm regrouping, just like I do with whole numbers. And 1 plus 2 plus 3 is 6, and nothing plus 6 in the single ones place is 6 single dollars, and one $10 bill plus no $10 bills leaves me with 1. Now, of course, with money in the United States, unless we're doing unless we're dealing with gas stations, we usually don't go beyond hundredths. So I erase those because now those zeros were making me feel a little seasick. So you got to take care of yourself, my friends. Here's some more money adding over here. 9 plus 5 is 14. Can I put 14 hundredths here? No, I cannot, my friends. No. Instead, what I'm going to want to do is leave the 4 hundredths there and take those 10 hundredths and trade them up for another tenth. Because 1/10 is equal to 10 hundredths. 1 plus 9 is 10 tenths. Aha! I'm going to regroup again, leaving 0/10 in the tenths place and using those 10 dimes to make me $1 bill, which leaves me with $3.04. Hey guys, thanks for playing decimals with me. I have so much fun playing math with you. Bye-bye for now.